In this worksheet, our first question is about the slope fields. Now, if you look at the equation, it means that when x is 0, which means that on the y-axis, the slopes will be equal to the y values at those points. And then when y is equal to 0, the slopes will be equal to the x values. Now, if you look at the first graph, on the x-axis, which is when y equals to 0, slopes always have to be equal to the x values. So when x is negative, the slopes should be also negative, which in this case it is. And when x is positive, the slopes should also be positive, which again in this case it is. But in the second one as well it works, but in the third one, when x values are negative, as you can see the slopes are positive, which cannot be the case according to our equation, so we're going to eliminate that. Now if you look at the y-axis, when y values are positive in the first one, our slopes are negative, which cannot be the case. And so we're going to eliminate the first one as well, and then we're going to look at the second one. And just to double check, when x values are positive, our slopes are positive. When x values are negative, our values are also negative on the x-axis. On the y-axis, when y values are positive, then our slopes are positive, and when y values are negative, our slopes are negative. So the graph that represents the slope field of this equation is the second graph. In the second question, we are asked to find a solution for a differential equation. So now, if we use our initial condition that when x is 0, y is 2, and if fx is 2, and if we apply it to what we see, we get a 0 over 0, which means that we need to use L'Hopital in order to solve these questions. Now the derivative of the upper side would be negative f derivative of x, and then the derivative of the bottom side would be, the denominator would be 2 times cosine 2x. So now if we apply the initial condition to what we seen, f derivative of x is equal to x plus y, as we were given in the previous question, as we can still see. So when if x is 0 and y is 2, then we get f derivative x to be 2, and we get negative 2 on the denominator side. So when we put 0 to x in the denominator part, we get a 2, and so the answer is negative 2 over 2, which is equal to negative 1. In the third question, we are asked to write an equation for the line tangent to the graph of f at x equals to 0. So now, we're going to use the first derivative, which is equal to, again, x plus y, which is in this case equal to 2. And then, since that was our initial condition that was given in the question, so our slope is 2. So we write the equation as y equals 2x plus c. Then in order to find the constant, we use our initial condition. When x is 0, y is 2, then c turns out to be 2. So our equation for the line tangent to the graph of f at x equals to 0 is y equals 2x plus 2. That is the equation. Now if we want to approximate f negative 0.5, we put 0.5 for y, and we get a 1. Now that is the first part of the question. And the second part of the question is, it asks if it's underestimate or overestimate. Now think about, now we need to find if the graph is concave up or is it concave down. We use the second derivative for that, and if we calculate the second derivative in this case, we get 1 plus y prime, and which is equal to 1 plus x plus y, because it was given that y prime is equal to x plus y. So now if we put our initial condition in there, we get the second derivative to be 3, which is greater than 0. Then it means that our graph is concave up. So let's just sketch how a concave up curve looks like. So in this case, if we take a tangent line to a point on the graph, the slope will always be smaller than the actual slope. So it will always go too low, which means that we are underestimating the actual answer. Because because the slope will never catch up with the actual slope, and it will always be too low when it's concave up. This is an Euler's method question. So we need to create a table using our fundamental elements of the values of x and y, delta y over delta x, and delta y. So the aim is just to write it in a fancy way of the number, which step are we in. That's not important, but the other 5 elements are important. So dy over dx is also equal to the slope, as we know, and as we were given in given the equation, that is also equal to the value of x plus y. Delta x would be our step size, and delta y would be m, the slope, times delta x. So we will do this in 2 steps of equal size. So our step size, so in order to determine our step size, we need to look at where we are going. We are going from x equals to 0 to x equals to negative 0.5. So we'll go negative 0.5, and if we divide it by 2, we get a negative 0.25. So that is our step size. Now, our initial condition was that f when x is 2, when x is 0, y is 2. So we are going to write that down, and then we find that since x plus y is 2, dy over dx is 2. So we write that down as well. These equations we were already given. So we complete the table by the last thing we do is that we multiply m by delta x, and we get negative 0.50. So now we add the initial y value with delta y, and we get 1.50. And then for x, again, we add initial x value and delta x, and we get negative 0.25. And then again we do x plus y in order to find dy over dx, and we get a 1.25 for that. So now that it's 1.25, our step size is still the same, negative 0.25. In order to find delta y, we need to multiply 1.25 with negative 0.25. And when we do that, we found the delta y to be negative 0.3125. So in order not to lose accuracy, I write all the decimals. You should too. And then y initial, since y initial is 2, and y final is 2 plus delta y, so which is equal to, in this case, 2 minus 0.5 minus 0.2125, which is equal to 1.1875. That is the value of phi when x is negative 0.5, approximately. This last question is concerning the Maclauren polynomial series. So we are going to use the Maclauren polynomial series to approximate the same value of f negative 0.5. So fx is approximately equal to f0 plus f prime 0 x plus f double prime 0 x squared over 2 factorial. This was the formula. First we wrote f prime, f double prime, f triple prime, and that, and then we put x squared, x cubed next to them, and then in each coefficient we wrote 0 factorial, 1 factorial, 2 factorial, and 3 factorial. But since 0 and 1 factorials are already 1, we don't write them down. f0 is equal to 2 as we were given, and f prime 0 is equal to, again, 2 as we were given. So our equation is going to start up. So we just need to find f double prime x, what is that equal to, and that's actually something we found already, and that's equal to 1 plus y prime, which is equal to 1 plus x plus y, as we said, since y prime is given as x plus y. And then when we put the variables inside the unknowns, we get f double prime to be 3. Now f triple prime is the third derivative of fx, is again 1 point y prime, which is again equal to 3 in this case. So we get a 2 plus 2x plus 3 over 2x squared, and then a plus 3 over 6, which is equal to 1 over 3. x cubed over x cubed. You don't need to simplify it, you can just write it down like this. This is the method of Maclauren polynomial series in order to approximate a value of fx. Now we put the value in, which means that we're going to approximate f negative 0.5. So we put negative 0.5 to wherever we see an x. So then it turns out to be, if you calculate it with your TI, 1.3125. And that is the answer.